if I'm going to take inventory on a section, and I can do inventory more frequently than just doing it with a barcode, how frequently should I do it? You know, if it takes me a little bit of people or effort or time to go out there and do it, versus having it done kind of automatically for me, how often do I need that data? How often is valuable? You can take that type of a problem and present it to the faculty, and the faculty can put their heads together and say, I'm going to do a research project, and I'm going to do it, and it's going to be published and go out there in a paper or journal somewhere. But it's also going to be something that someone wants to use right away in the industry. So it's trying to, I guess, build that connection and make things more immediately relevant. Here we go. The floral shorts, the shirt, and the swordfish shorts that all took into that room with me are on that screen. That's good from just an inventory control perspective. I know what's going in the dressing rooms. I can use it for loss prevention if we're looking at theft issues, but more importantly, I can use it to help the customer shop better. So if an associate knows what the customer put in there, then maybe they can kind of help pick out some things that they might also like, or what the customer can do is say, oh, I took this orange shirt in here, I got the wrong size, hey, can I send something to an associate and they can bring you the right size, and the associate already knows what the item is that's in there. RFID is not perfectly exact a lot of times because it is a radio wave and it does bounce around a little bit, but we have inventory all the time. For those of you who worked in a retail store, going out there and taking inventory is miserable. You got to scan things one at a time. Not having to ever scan at all, but continuously know this, it's a big bonus. And then what I'm going to do is take this a step further and filter it. And Logan, we can take these back over there. I'm not sure if that filtered correctly. So whenever he took the pants over there, you'll see the green dot start moving that way. It's on a refresh rate, so it takes a second, so you actually see that dot move back over where he's standing back by the wall over there. And then if he brings the item back over this way, then in a few seconds, you're going to see that green dot relocate back here to this area. Tags that go on the items, they beep if you know when you purchase something at the store, they're supposed to scan it over the scan pad and deactivate it. It beeps if you go out the exit, you have deactivated it. This is the same type concept. In this instance, we have a RFID tag on the back of this pair of jeans here. So whenever I take this out through this exit, you'll hear that beep. So that's not that much different than what you've seen with the traditional EAS tags before, but what's really different is what's happening behind the scenes, because that exit actually captured exactly what kind of item went out that door and exactly how many items went out that door. So from a theft and loss prevention perspective, that's a huge change. That's a big, big difference in how we manage stores.
Well, if you guys can step closer, you can come closer if you like. But this is the chamber area. This is the anechoic chamber. And this is where we do all of our testing. So as you can see, it's a completely metal box on the outside and it's lined with copper. And the foam that you see on the inside is to help prevent reflection from the frequency during testing. So this is how we run our test. So when the test we're running, the table rotates to different angles. Because at different angles, you get different test measurements. So the test measurements vary depending on the angle that the frequency is hitting the product.
There you go, for 200. These shirts and these boxes, they're hooked to a reader. They're shooting radio frequencies into these boxes, and they actually talk to the tags. The tags have individual antennas, which we can show you a tag, but they actually have antennas and a microchip that knows its name. And so it's looking for just anything they can talk to, and when it bounces back, it reads it, knows its name, and it pops it up on the screen.
You know, for students at Auburn, this is a great opportunity, right? Being at Auburn is step one. It's a great school, great education, tremendous foundation in engineering and technology. And this lab puts them on the cutting edge of a new technology.
1, 2, 3.